The periodic table is the way we keep the elements organized. They are organized on the basis of their atomic number or the number of protons an atom has. Dmitry Mendeleev is given credit as being the first to organize the elements in this way, though many changes have been made through the years. Mendeleev put together his first table based on the 65 elements known at the time. Because the structure wasn't known, he used the chemical properties of the elements to help. The elements were arranged in order of increasing mass. What was truly prescient was that he left spaces for undiscovered elements and predicted some of their physical and chemical properties. This is an example of a modern periodic table. Note that each box contains the atomic number, the name of the element, and its symbol. The other number is its average atomic mass, which we will define shortly. The periodic table can give you a lot of information if you know where to look. One way to look at the periodic table is by breaking the elements down into categories: metal, nonmetal, and metalloids. The metalloids separate the metals from the nonmetals. They are comprised of boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine. Often polonium and astatine are not included. The metalloids have properties between those of metals and nonmetals. Because of its unique properties as a semiconductor, silicon is used for making computer chips. Metals are found to the left of the metalloids, except for hydrogen, which is a nonmetal. Metals are good conductors of heat and electricity, malleable, ductile, shiny, and their atoms can give up electrons to gain a positive charge. All are solids at room temperature except for mercury, which is a liquid. Nonmetals are found to the right of the metals, but also include hydrogen. Many are gases at room temperature, a few are solids, and one, bromine, is a liquid. They are poor conductors of heat and electricity and form negative ions when they react with metals. There's another way to look at the periodic table, which we'll find correlates with the electronic structure of the atom. The longest columns are the main or representative group elements. Those in the short columns are the transition elements, and the two rows often placed below the bulk of the table are the inner transition elements. Those two rows of elements actually belong in with the transition elements, but would end up making the table much longer. You should know how to assign each element to two groups. For example, gold, or Au, is the transition element and a metal. Germanium, Ge, is a main group element and a metalloid. Just like with a spreadsheet, there's a distinction between columns and rows. Columns are vertical. The elements fit into groups or families. Rows are horizontal. They are also called periods. We also assign some groups of elements their own names because of their chemical similarities. The first two columns of metals are referred to as alkali metals and alkaline earth metals, respectively. The alkali metals are especially reactive towards water and create an alkaline or basic solution. The alkali earth metals are not quite so reactive with water, but also form alkaline solutions. None of these metals is found in the pure state in nature. On the other side of the periodic table are the noble gases and the halogens. The noble gases are especially unreactive. No compounds containing noble gases have been found in nature. The halogens, on the other hand, are very reactive with metals, especially those in the alkali metal column. In their pure form, chlorine, bromine, and iodine are either gases or can easily be put into the gas state. They are quite colorful. This is a review slide. It has a lot of information in it.